Today I want to talk about how street light works. First, smart lighting using microprocessor. Secondly, the overview of automating street lights using microprocessor improve efficiency and reduce and maintaining safety. I will discuss the systematic overview of the components and how street light works. There are a few components in the street light. The main component is the processor, the microprocessor, light, sensor, relay, driver circuit, street light, LED, and lastly, power supply. Those components are very important in the smart street light. Smart street light flowchart. In the flowchart, you see in the diagram before it works, it will be starting it will read light sensor LDR. When it is dark, yes, the street light will turn on, and when it is dark, no, the street light will turn off and repeat it. The microprocessor room is full of key components and CPU architecture. There are three rows of microprocessor. Each read input from sensor and process logic to determine light condition and control output to switch lights via relay. In summary, it reads input from sensor and process logic to on the light. The visual of key components: microprocessor inter-switch light, CPU block diagram, computer process light data, address and control. Lastly is the memory. This visual helps to explain how to flow from the sensor input to light control output. CPU architecture. Through the ALU, ALU is performing the logic operation and move down to control units. Control unit is to direct operation after the control unit is moved down to the register. Register is to store data temporarily, and lastly is the process. Process is to connect to CPU to memory. I will talk about how the bus system and memory architecture in the street lights. Data bus, address bus, and control bus, ROM and the RAM. Data bus is how to transfer the actual data. Address bus is to carry the memory to address, and lastly, control bus is to send control signals. The ROM is to store the program code, and RAM is the temporary data during execution, and lastly, the EEPROM is to store the settings, for example, light thresholds. In the real world, mostly in the overseas or development countries, for example, smart cities, highway lighting, and energy conservation projects. To conclude, microprocessor-based street lights are more efficient, scalable, and intelligent, and they represent a key step towards sustainable for urban infrastructure.